Spooner High School recently acquired a 3D printer, a printer that uses material in an additive fashion to form physical products. Students create computer-aided designs and input the information into the 3D printer, which creates the object.
Got a metals class now, and their project is the kids are going to design and make these on the big CNC machines and all that. Before they did that, they prototyped this with Alex's help over there, so that they knew that the design would work right. And so now it's gone from this to this will be the finished product actually manufactured on those other metal machines, lathes, and CNC.
So this was made with that 3D printer.
Yeah, this was printed off.
Is it now? This is a stupid question. But was it made in steps, or how is it made?
Here's the finished product. It's a nut and a bolt.
Yeah.
So when it's printing off over here, it's two pieces. So there's actually two pieces printing off on that plate there. So the example of that's several pieces that assemble together into one assembly.
Okay.
And so each of the pieces is laid out and printed at the same time as one job, but then you take them off there and you assemble them once it's done. So once it's done here, you take these off and screw it together for your finished product.
Why do we call it a printer? It's actually it's more like, I don't know. It's not sculpting, but it's like it's additive, right?
I guess I would use the analogy of when you go to print a traditional print job, you create a product in Microsoft Word as an example. When you're done, you print. Here, Alex goes and he designs something in some sort of CAD software. In the case, he's been using mostly SolidWorks.
Yeah.
Once his product is designed, he transfers it onto a little card here, SD card, and then that's like sending it to your printer. So the machine is taking the information from there, and it's laid out in the file, and it's laying it out and building it up layer by layer, much like
what's it building? Is it using like taking liquid plastic or something?
Actually, if we step around that, so that's just it rolls up through here. The printer then heats it up and it lays it down just almost like the width of a hair.
Width of a hair. Oh, okay.
And so what you can do with these designs is you can vary the tolerances and the thickness. So like this is semi-hollow. This little turtle Christmas ornament thing. Whereas this is a solid nut and bolt where it's actually solid plastic. Over here's an example. So what this is he's got a roof rack on the car. He's designed a bracket that clamps onto the roof rack, and this, using the tube, is to create a cross piece to put a canoe on.
Is this the original one?
This is his prototype. The first one didn't quite work out because he saw he had some problems. This is going to be his finished product.
That's another second one he made.
Yeah, this cylinder head here, which was designed by Alex over there, where he's taken the cylinder head of a snowmobile and he races snowmobiles. He wants to improve the performance by increasing the combustion chamber size, so he has redesigned the inside of the cylinder head to be deeper than what the original was. He's going to use this to make a casting that he will then finish final machining over. So this actually costs about $15 to make.
It was made on how long did it take to make that?
This was 19 hours, right, Alex?
19 hours?
Alex, this took 19 hours.
Yes.
So it literally took 2 days to print off
2 days
because of the complexity and the amount of material in it. So, but basically what you see here, everything was printed off the way it was. Just slight tweaking, printing out. But so we're going to work with Nexon, and they're going to hook us up with a company that does casting. We're going to use this as a prototype to create the cast for him to then go back and do the final machining using the various metal machines over.
We're going to create a cast with that.
Yeah, they're going to create a cast with this, and then he'll go back and clean up some of the rough edges. Obviously make this nice and smooth.
On the metal version.
Yeah. Right. But this gave him an idea as whether or not it's going to fit right. It's got the right depth that he's
good classroom.
Both, Mr. Cornell, Mr. Boyer's classrooms for everything from design to the metals and woods manufacturing and that.
This might also be used for the art department.
Yeah.
Down the line.
Initially, we're starting in tech ed, but Mrs. Dome has expressed an interest in 3D graphic arts, so we're going to be working with her to pilot some there, and then possibly would like to see it move out into the math and science areas where they can do things with geometric shapes.
Right.
things like
So this
that.
might just be the first of many of these printers that come into the school district. Maybe.
Potentially, I mean,
Potentially,
it'd be
yeah.
based on curricular need.
All right. Well,
It
they're
has a very practical application for what we're doing in tech, rapid prototyping.
and this is what's happening in manufacturing. This is just another outlet.
It's kind of, the idea is to teach our kids some of the skills they might run into once they leave here and go out into the real world. So,